Let's say we have a graph provided to us. I'll show it in the form of a graph, but it might be provided to us in terms of functions and equations. So let's say we have something like this, okay, and we have this, and we have this, and we have something like this. Okay, so here important thing is we have, let's say this is 2, this is 4, and this curve is x square, and this is y equal to 1. So if you notice, I have a boundary here, I have a boundary here, I have a boundary here, and I have a boundary here. So I have a area bounded by these curves. So these curves are x equal to 2, x equal to 4, y is equal to 1, and y is equal to x square, right? And what I also have is the axis of rotation. Let us say that is y equal to 0. That is the x-axis itself. So what we are going to do is rotate this graph across the x-axis. So what I would end up with is a solid which is bounded by these curves, and in between there would be a hole. So let's say something like this, and I would have something like this, right? So in between there will be a curve. So we have to figure out the volume of this solid formed by the rotation of an area. So how do we figure out this volume? If you notice, if we slice this, we would get a circle. So if I look at it from um, the x side, I would end up with a circle, an inner circle, and an inner circle, and this circle would keep becoming smaller and smaller and smaller. Yes, if I look at it from this side, the circle which I'm interested in will be formed by this bounded region. So each slice would be a circle, but the radius of the circle keeps increasing if we go from this side to this side. Okay, is take the area of the circle and integrate it in the interval of 2 comma 4. That would give us the volume. We know the area of a circle is pi r square, and radius would be formed by this part only. So r would be nothing but y is equal to x square, okay, as far as the circles are concerned. But in between there is a hole formed by these two, this line being rotated. So this would be r1, and I'll have r2, y equal to 1. Now another thing is axis of rotation might be y is equal to 1 itself. In that case there will not be any hole in the middle. Okay, let's solve problems. Let's say we have a function y is equal to square root of x, y is equal to 0, x equal to 1, and y is equal to 0 is the axis of rotation. That means there is no hole in the middle, because this curve and this, they are on the same, they are collinear basically. So what do we do? Let's first figure out the graph of this, a rough graph. Square root of x would go like this. 0, y equal to 0 is this itself, x-axis. X is equal to 1 would be this, right? So the area that we are interested in is this area bounded by these three curves, this, and this. This is the axis of rotation. And we are going to rotate it across x-axis. So it would go something like this. So this area we figure out and we integrate it using the area of the circle, or we integrate the area in this interval. So let's see. Now volume would be integrate. Now from where to where? Remember, this is 0 and this is 1. So 0 to 1. Area of the circle is pi r square dx. Right? Now the radius is going to be the function that is given to us, that is square root of x. Pi is a constant, we can take it out, dx. At any given point, the a point on this curve is going to be the will give us the radius. So that is why square root of x dx. Okay, so pi, and here r square it is, so square. So integral 0 to 1 x dx. Now it's pretty straightforward, right? X square by 2, 0 to 1, which gives us pi 1 by 2 minus 0, which gives us pi by 2 cubic units. Okay, second one, we have y is equal to minus x square plus 1, y is equal to 0. The interval that is given to us is x equal to -1 and x equal to 1. So basically it means -1 to 1, right? And our axis of rotation is y equal to 0. So let's briefly look at the graph. We have minus x square. So that means it is concave down. So it would come like this. But we are interested in -1 to 1. So let us say, is it going to be this? You need to be very careful. So minus x square plus 1 equal to 0, minus x square equal to -1, x equal to plus or minus 1. So this is the curve, not this part. 1 to -1 to 1, this is the curve, and y equal to 0 is nothing but the x-axis itself. So this is the area that is we are going to rotate across the x-axis. So volume would be, since we already know pi, integral from -1 to 1 of r square. R square is going to be minus x square plus 1 dx square, -1 to 1 minus, no, plus x to the power of 4 minus 2x square plus 1 x. This gives us pi x to the power of 5 by 5 minus 2x cube by 3 plus x from -1 to 1. 1 by 5 minus 2 by 3 plus 1 minus -1 by 5 minus times minus plus 2 by 3 minus 1, which gives us, if we solve this, we would end up with 16 by 15 cubic units. Okay. Third one. Again, we have y is equal to x square plus 1. Y is equal to 0. Top and bottom boundaries. -1 to 1. These are the vertical boundaries. These two are horizontal boundaries. More or less horizontal because it's a curve. So let's get an idea. X square plus 1. It is concave up. So x square plus 1. Where would we intersect? X square plus 1 equal to 0. X square equal to -1. So we don't have to bother with it. It is imaginary. Now, it could be something like this. Okay. Y is equal to 0. That is this x-axis itself. -1 to 1. So this is the area that we are going to rotate across the x-axis. So axis is equal to y equal to 0. That is the x-axis itself. So again, if we slice it, take it piece by piece, we'll get circles. So volume would be equal to integral from -1 to 1. We know pi is a constant, we can take it out, r square. R square is x square plus 1 square dx. Okay? So pi -1 to 1 x to the power of 4 plus 2 x square plus 1 dx, which gives us pi. Okay, let's integrate it. X to the power of 5 by 5 plus 2 x cube by 3 plus x from -1 to 1, which gives us 1 by 5 plus 2 by 3 plus 1 minus -1 by 5 minus 2 by 3 minus 1. So this would give us 2 by 5 plus 4 by 3 plus 2, which gives us 56 by 15 pi cubic units. Okay, fourth one, y is equal to 1 by x, y is equal to 0. This is the top boundary and the bottom boundary. And this is the left boundary and the right boundary. And the axis of rotation is y equal to 0. So graph would look like something like this. So it would go something like this: 1 by x, 1 by 5 and 5. So this is the area bounded by these three curves. And we are going to rotate it around the x-axis. So volume would be pi integral from 1 by 5 to 5 of pi r square. So pi is out, r is 1 by x square dx. So pi, let's integrate. We will get x to the power of -2. So -2 plus 1 is -1. So 1 by x divided by -1. So minus from 1 by 5 to 5, which gives us -1 by 5 minus minus 1 by 1 by 5, which means, no, this is, that is going to be 5, which gives us pi -1 by 5 plus 5, which gives us 25 minus 1 is 24 by 5 pi cubic units. Okay, that was the fourth one. Fifth, y is equal to square root of x plus 6. Y is equal to 0, right? And the interval is -4 to -1, and the axis of rotation is y equal to 0, right? Now, square root of x is going to be something like this, right? Square root of x plus 6 would be what? It would go something like this. Y is equal to 0 is the x-axis. -4. So let's just see. -4, if we take, -4 would be -4 plus 6. That is 2 square root of 2 would be somewhere 1.414, right? So that would be something like this. So this is -4 and -1. -1 plus 6 is, it is -1, it will be something like this. So this is the area that we are interested in. So when we rotate this area, we get a solid. So the volume of that would be pi integral, because why we are taking it as pi r square is because when we rotate it, we slice it, each slice would be a circle. So pi r square, that is square root of x plus 6 square dx, which is equal to pi, and this interval would be -4 to -1. Pi -4 to -1 of x plus 6 dx. Now let's integrate this. We get x square by 2 plus 6x from -4 to -1, which gives us pi 1 by 2 minus 6 minus 16 by 2 minus 24. Pi 6 to 12 minus 11 by 2 minus, okay, this is 2 8. 8 minus 24 is minus 16, minus is plus, so plus 16, which gives us 21 by 2 pi cubic units. Sixth one, y is equal to 2 square root of x plus 1, y is equal to 0, and the interval is 5 to 7. Okay, and the axis is the x-axis. Graph would look something like this: square root of x plus 1, so it will go something like this, times 2. So let's take it a little bit further. All right, y is equal to 0 is this x-axis itself. 5 to 7, so 5 to, let's say, 7. So this is the area that we are interested in. Again, if we rotate it and we slice it, we get circles. So volume is equal to pi integral from 5 to 7 of the y. So that would be 2 square root of x plus 1 square dx, which gives us okay, 5 7 4 times x plus 1 dx, which gives us, if we integrate it, we get 4x. So 4x square by 2 plus 4x from 5 to 7. 2 to 5. Let's do the substitution. 7 square is 49. 49 2s is 98 plus 7 4s 28 minus 5 square is 25. 2s 50 plus 20, which gives us 98 plus 28 gives us 8 to 16, 126 minus 70. 126 minus 70 is 56 pi cubic units. Seventh one, y is equal to minus x square plus 5. Y is equal to 1 is the second boundary, and the third and fourth boundaries are defined by this vertical lines, x equal to 0 and x equal to, okay, now our axis of rotation is y is equal to 0. Now comes the hole in the middle, remember. So because the axis of rotation and this curve, they are not same, so here you have this axis of rotation and you have this y equal to 1 and you have minus x square plus 5 from 0 to 2. So it would go like this. Let's say this is, it will go like this. Okay. Boundary that we are interested in is this. If we rotate it, there will be a hole in the middle. This will be the hole. So we have to figure out the area of this curve, and then from that we have to subtract this area. Then we have to integrate it to get the volume. Let's see. Here also the slice would be a circle. So volume would be integral from 0 to 2. Now here, which is the higher curve? Minus x square plus 5 is higher. So from that we have to subtract the area of the bottom curve, area under the curve. So what we'll end up with is pi r square. that is minus x square plus 5 dx square. Here we have to subtract the area under the curve of this line y equal to 1. So that would be pi, and the r is given by y, that is 1 square dx. So now 0 to 2, pi goes out. This becomes x to the power of 4 minus 10x square plus 25 dx minus pi is again constant, 0 to 2 of 1 dx. Now let's integrate. Pi we can take it out common. The power of 5 by 5 minus uh, 10x cube by 3 plus 25x. 0 to 2 limits are same, minus x from 0 to this gives us x to the power of 5 by 5 minus 10x cube by 3 plus 24x from 0 to 2. And if we solve all this, we get 416 pi cubic units. Okay, that was the seventh one. Now eighth one. Y is equal to cube root of x. Y is equal to 1 is the second boundary, and x equal to 0 and x equal to 1 are the vertical boundaries. So the graph would look something like this. X equal to 0 is the y-axis, x equal to 1 is this. Cube root of x, yes, it would go something like this. It goes something like this. So here this part only we are interested in. And y is equal to 1, that will go like this. So the area bounded by all this is which area? Bounded by this, bounded by this, in this interval. So that is this. Now here, which is the higher curve? Y is equal to 1 is higher. So which means the volume, and if we slice it, we would still get circles. So y is equal to integral from 0 to 1 of higher curve is y equal to 1. R is going to be 1. So pi times 1 square dx. From that we have to subtract the area under this curve. So 0 to 1 of pi square dx. Now let's integrate this. We get x, I is there, from 0 to 1 minus, now if we integrate this, we get pi x to the power of 2 by 3. So x to the power of 2 by 3 plus 1, that gives us 5 by 3 by 5 by 3, which can be written as 3 by 5 from 0 to 1. Okay, this becomes pi, substitutions 1. So pi minus pi, and here what would we have? We would have 3 by 5. 5 pi minus 3 pi is 2 pi by 5 cubic units is the answer. Ninth one. Y is equal to minus x square plus 5. Y is equal to 1. The interval is minus 2 to minus 1. And the axis is x-axis. Y is equal to, so let's look at the graph. Minus x square, so concave down, plus 5. So it would be something like this. And y is equal to 1 is something like this. Minus 2 minus 1. So if we take minus 2 square is 4. So y is equal to 1. So when x is minus 2, y is 1. The other end would be minus 1. So this. So the area of interest is this, bounded by this curve, bounded by this. and bounded by this. So again, if we rotate it, we slice it, we get circles. So volume is equal to, and the axis of rotation is y. So that means there is going to be a hole in the middle. So volume, and here, which is higher, this curve or this curve? Minus x square plus 5 is higher. So from that we have to, from the area under the curve of this, we have to subtract the area under the curve of this. So pi integral from -2 to -1. Remember, this is higher. So minus x square plus 5 square dx, right? From this, we have to subtract this. So again here, pi -2 to -1 of the radius is 1 square dx. Expanded. So pi, let's take common out. Integral -2 to -1 x to the power of 4 minus 10 x square plus 25 minus 1. This one also, let's take it in. This entire thing dx. Okay. Now let's integrate x to the power of 5 by 5 minus 10 x cube by 3 plus 24x from -2 to -1. This gives us -1 by 5 plus 10 by 3 minus 24 minus, this would give us 2 to the power of 5, 32, minus 32 by 5, minus times minus plus, x cube is 8, so 80 by 3 minus 48. If we solve all this, we would get 103 by 15 pi cubic units. Let's say 10th, y is equal to minus x square plus 8. Y is equal to x square. Now these two are the curves. Now in the previous examples we had a straight line as the other boundary. So here we have another function which is not a straight line, and the interval is 0 to 1, and the axis of rotation y is equal to let's say 0. Okay, now let's look at the graph, what it would look like. Let's say this is 8. Okay, so minus x square, so that means it is going to be concave down, but the interval is 0 to 1, so it would be something like this, right? And y is equal to x square, so it would be something like this, and the interval is 0 to 1, right? So y-axis itself would be one boundary and the other boundary would be this. So we have to look at this boundary, this area. So to figure out this, so we take the area under this curve and subtract the area under this curve, and then we integrate it across 0 and, okay, let's see. Volume is equal to, again slices will be circles, so pi 0 to 1 r square. Now which is the higher curve? Higher is this. So minus x square plus 8 square dx, and from this we have to subtract integral 0 to 1 of pi, the area under the other curve, that is x square dx. This would be pi integral from 0 to 1 of x to the power of 4 minus 16x square plus 64x minus pi integral of x to the power of 4 dx from 0 to 1. Now pi is common, so let's take it out. x to the power of 4 is here. So this, when we integrate, becomes x to the power of 5 by 5 minus 16x cube by 3 plus 64x minus x to the power of 5 by 5 from 0 to 1. This and this cancels, and we are left with minus 16x cube by 3 plus 64x from 0 to 1. This gives us pi. Substitution, we get minus 16 by 3 plus 64, and the other part all becomes 0. So we can leave it at that. This, if we evaluate, we get how much? Pi minus 16 plus 3 fourths 12, 192 by 3, which gives us 12 minus 6 is 6, 8 minus 1 is 7, 176 by 3 pi cubic units. Okay, now the 11th one. Y is equal to x square plus 2. Y is equal to 2 is the other boundary. X equal to 0, x equal to 1. These are the interval, x interval. Axis of rotation with it. So axis of rotation is y is equal to 0. Okay. So what would the graph look like? X square plus 2 from 0 to 1. So x square plus 2 would go like this. Y is equal to 2 would be this. Interval is 0 to 1. Let's say this. So this is the interval that we are interested in. And this we are rotating it across x-axis. So which means there will be a hole. So our volume would be pi, which is higher. X square plus 2 is higher. So integral from 0 to 1 of x square plus 2 square, and we can combine the steps into one single one. From this we subtract the whole, so that is 2 square dx. Now let's solve this. Pi, let's simplify it first. 0 to 1 of x to the power of 4 plus 4x square plus 4 minus 4 dx. 4 cancels, and now let's integrate. X to the power of 5 by 5 plus 4x cube by 3 from 0 to 1. Okay, pi 1 by 5 plus 4 by 3 minus 0. So this gives us 15, 3 plus 20. So 23 by 15 pi is the volume in cubic units. I thought we were done, but it seems I missed one problem in the middle. So basically the 12th one I missed it. So let me do it in the end. So y is equal to minus 1, y is equal to minus x square. If the interval is minus 1 to 1 and the axis is y is equal to 1. Okay. So let's see where they intersect each other. So minus x square is equal to minus 1. So x square is equal to 1, which means x equal to plus or minus 1, which is the endpoints of this interval. Right? So perfectly fine. So let's see what the graph would look like. So minus x square would be something like this. Okay. And we have minus 1 and 1. So this will be one line, y is equal to minus 1, and this is our interval, and our axis of rotation is y is equal to 1, right? and the area of interest is which one? Bounded by this. So this plus this. So this entire thing. So for this we have to subtract, take the area of this rectangle and subtract from it this area. And we also have to take care of the hole created by this empty space when we rotate this. So let's follow the trick which we saw previously. Let's shift this to 0, the axis of rotation. So which means we have to make it -1, which means this will also be -1 and this will be -1. So which means our functions would be y is equal to -2 and y is equal to minus x square minus 1. Okay. So now the volume would be integral from -1 to 1 pi is there r square. So let's take one of these. Now, which is the curve which has the largest area under it? That is our rectangle has the larger curve, which means this one. So we will say -2 square minus, and here we have the other curve that is minus x square minus 1 square. Yes. Yes. Now let's evaluate this. Pi integral from -1 to 1 of 4 minus this minus, we can take it common out, and when we square it will become plus. So what we will end up with is with this minus x to the power of 4 plus 2x square uh, plus 1. Yes. So we have pi. And now let's actually simplify this and integrate at the same time. 4 minus 1 will give us 3 minus x to the power of 4. Now, when we integrate it, it will become 3x minus x to the power of 5 by 5 minus 2x cubed by 3 from -1 to 1. So now pi, let's do the substitution. 3 minus not x, 1 by 5 minus 2 by 3 minus, this will become -3 plus 1 by 5 plus 2 by 3. Okay. Now let's simplify this. 3 plus 3 is 6. 1 minus 1 by 5 minus 1 by 5 is minus 2 by 5. Minus 2 by 3 minus 2 by 3 is minus 4 by 3. Which gives us, if we evaluate this, what do we get? We get pi times 64 by 15 cubic units. So that was volume by slicing method. That's it. Bye. 13th one. If y is equal to minus x square plus 6, y is equal to minus x plus 4. This is a line, this is a quadratic parabola. Interval is 0 to 2 and the axis of rotation is y is equal to 1. Now let's figure out the graph. Uh, Before we actually do that, let's see whether these two intersect each other. So minus x square plus 6 is equal to minus x plus 4. So x square minus x minus 2 equal to 0. This will, if we solve this, we will get x equal to minus 1 or 2. Minus 1 is out of our interval, so we don't need to look at that. 2 is at the boundary. So when x equal to 2, y is what? We can take any one of these. So the point of intersection within our given interval is minus 2 plus 4. So minus 2 plus 4 is 2 comma 2. So this is our y is equal to 1. Minus x square plus 6 would go like this, and we don't really have to go beyond this, because this will be our point of intersection, that is at 2, and the line minus x plus 4 would go something like this. Okay, so this is the area that we are interested in, and this we are going to rotate it across y equal to 1, right? So we have to look at this. So what do we do in this case? What will be the radius? Remember, this is with respect to x-axis, but here our axis of rotation is one more. So this part we have to remove. In the previous example, we added one part. Here we have to remove this part. So to remove, when we remove that part, what will be the radius? That is what we have to look at. So our volume would be pi integral from 0 to 2 of, which is higher, this curve is higher, so minus x square plus 6 minus 1, this part square, that would be the radius, minus integral, again pi is there, 0 to 2 of the other one, so minus x plus 4 minus 1 square dx. So here also we will have dx. Again, be very sure that you understand how this came about. So now, once we have that, then it's pretty straightforward. 0 to 2, this is going to be square, so let's write it as minus x square plus 5 square dx minus pi integral 0 to 2 of minus x plus 3 square dx, which gives us pi integral 0 to 2 of x to the power of 4 minus 10 x square plus 25 dx minus pi integral from 0 to 2 of x square minus 6x plus 9 dx, which gives us pi. If we integrate it, we get x to the power of 5 by 5 minus 10x cube by 3 plus 25x. Since the interval is same, we can incorporate this also. So this would be minus x cube by 3 plus 6x square by 2 minus 9x from 0 to 2. Pi x to the power of 5 by 5 minus uh, 11 by 3 x cube. 25 minus 9 is plus 16x, and we also have x square, 2 3, so 3x square from 0 to 2. Now pi 32 by 5 minus 11 by, not 11, 2 cube is 8, 88 by 3 plus 16 to 32 plus 2 square is 4, 4 3 is 12. minus 0. So no problem. And if we do all these calculations, we will end up with 316 by 15 pi cubic units. Yes. So basically here the most important part is being able to visualize the graph. Then the chances of you making a mistake is very less. Any mistakes that you make would be more related to algebra kind of. 14th one. Y is equal to minus x square plus 7. Y is equal to 3. Interval is minus 2 to 2. And the axis of rotation is y is equal to 2. Right? Now, to get the graph properly, we need to know whether they intersect each other. At which point? So, x minus x square plus 7 equal to 3, minus x square is equal to minus 4, x equal to plus or minus 2. But that is the interval, minus 2 to 2. So, that is one piece of information we have got. Now, the second piece of information that we require is at what points do they go to 0. So minus x square plus 7 equal to 0. X square is equal to 7. So x equal to square root of 7, which is greater than 2 less than 3, but it is much closer to 3. So x is greater than 2.5, which is outside this interval. So that is another piece of information we have got. So let's see what the graph would look like. So we have y is equal to 2 as the axis of rotation, y equal to 2. Then we have y is equal to 3 between minus 2 and 2. So this, and we have the parabola. So it would go something like this. So when we rotate it across y is equal to 2, what would be the radius of the cylinder formed by this straight line? From 2 to 3, this is y equal to 3. So radius would be 1. Yes. And with respect to this parabola also, the radius we have to reduce it by 2. Why? Because we have we had 3 minus 2, 1. So similarly here with this function we have to reduce it by 2. So our volume would be integral, which is the higher function, x square. So minus 2 to 2, pi is common, and we will have minus x square plus 7, and we have to do minus 2 square. Okay? Then from this we have to remove the hole that is formed, because it would be on this side, it will be like this. So this will be the hole, and the radius of this hole is 1. So 1 square. Again, be clear that you have understood how we arrived at this. Okay, so pi integral minus 2 to 2 of x to the power of 4. 7 minus 2 is 5. So 5 to 10. So minus 10 x square. Pi square is plus 25 minus 1. So pi integral minus 2 to 2x4 minus 10x square plus 24 dx, which gives us pi, let's integrate it, x to the power of 5 by 5 minus 10x cubed by 3 plus 24x from minus 2 to 2. Again, if we can do it step by step, it just takes time. So I'll avoid that and say if you evaluate this, you will end up with pi times 832 by 15. That is the volume. 15th one. Y is equal to minus 4. y is equal to minus x square, interval is 0 to 2, and axis of rotation is y is equal to 1. So again, let's see. uh, Minus x square would go something like this, but we are interested only in the 0 to 2 interval, so it would go something like this. Okay, then minus 4. So if we put 2, we get 2 square minus 4. So we will have something like this, and our interval is this, y-axis and this. So our area of interest is which one? Enclosed by this curve, enclosed by this, enclosed by this, enclosed by this. So we are interested in this part. But our axis of rotation is y is equal to 1. So our axis of rotation is y equal to 1. Yes. So which means this much area we have to add. So our volume would be pi, we can take it out. Integral from 0 to 2 of which is higher, which has a larger area under the curve, this straight line, this boundary. So that would be 1 minus 4 square. Basically 1 minus 4 is basically, look at this, when it is 2, this is going to be 4, right? So 0 to 4 we already have 1, and here we have 4. So which means 5 is going to be the radius of the cylinder that is formed by rotating this line. Now from this we have to remove the area under this curve. So that would be again 1 minus x square dx. Again, be very clear of what we are trying to achieve. So dx. So actually, let's take this. Okay. So now pi integral 0 to 2. This becomes 5. 5 square is 25 minus this would be 1 plus x square square. So 1 plus 2x square plus x to the power of 4 dx. Actually, you know what? This dx should be outside. Let's simplify this. We get 0 to 2, 24 minus 2x square minus x to the power of 4 dx. And now let's integrate. Pi 24x minus 2x cubed by 3 minus x to the power of 5 by 5 from 0 to 2, which gives us pi 48 minus 8 to 16 by 3 minus 32 by 5 minus 0, which gives us, if we do the calculations, we get 554 by 15 pi cubic units. 16, y is equal to 2x minus 1, y is equal to x square minus 1. Interval is 0 to 2, and the axis of rotation is y is equal to minus 2. Let's see whether they intersect each other. So 2x minus 1 equal to x square minus 1. So 0 is equal to x square minus 2x 0. So this common x we take it out. So x minus 2. So x equal to 0 or x equal to 2. But that is the interval that is provided to us. So at the endpoints only they intersect each other. Clear? Okay. Now let's draw the graph. our axis of rotation is -2, and 2x minus 1, minus 1 is going to be the y-intercept of this line, and the slope is positive 2, and x square we know goes something like this, right? So which means the straight line goes like this, and that means the first intercept is at 0, second intercept is at 2. Okay, now which means we have to adjust our integral, right? So let's see what we can do. What can we do to this axis of rotation to bring it to 0? We add 2 to it. Since we have added 2 to the axis of rotation, let's add 2 to this, let's add 2 to this. So what do we end up with? Axis of rotation becomes 0, y becomes 2x plus 1, and the other one becomes x square plus 1. And now we evaluate the volume of this, because just shifting these shapes, keeping their distances equal, to what they were, we don't actually change the area or the volume. So pi integral 0 to 2 of 2x plus 1 square dx minus pi integral 0 to 2 of x square plus 1 square dx. Now it is pretty straightforward. 0 to 2, 4x square plus 4x plus 1 dx minus pi 0 to 2 of x to the power of 4 plus 2x square plus 1 dx. So what do we get? Let's actually do the calculation, or what we can do is put them together. 0 to 2, 4x square minus 2x square, x to the power of 4, let's write it first. So minus x to the power of 4, 4x square minus 2x square, so plus 2x square. Then we have plus 4x, 1 minus 1, 0. So dx. Yes. So now pi, let's integrate minus x to the power of 5 by 5 plus 2x cube by 3 plus 4x square by 2. So these two cancel out. From 0 to 2, pi minus 32 by 5 plus 16 by 3 plus 2 square is 4, 4 2 is 8 minus 0. So what do we get if we do all this? We get 104 by 15 pi cubic units. Okay, next one, 17th one. Y is equal to minus x minus 4, y is equal to minus x square minus 2. Interval is 0 to 1, and the axis of rotation is y is equal to minus 1. Okay, first let's see where they intersect each other. So minus x square minus 2 is equal to minus x minus 4, which gives us x square minus x minus 2 equal to 0. So this would be x minus 2 minus 1. So one of them has to be minus, yes, equal to 0. X is equal to minus 1, 2. But our interval is 0 to 1. So that means within this interval there is no intersections. Great. So when one very nice piece of information. Now y minus x square minus 2 equal to 0. What will be the zeros? Minus x square is equal to 2, x square is equal to minus 2. So imaginary, so don't intersect the x-axis in the real world. Okay. So I think that is enough information for us to draw a rough graph. So what is our first function? Minus x minus 4. Minus x, that means slope is negative. So it goes downwards. And y-intercept is minus 4. So let's say this is minus 4. So minus 4 minus x minus 4. So it would be something like that. And this is our 1. Now what about the other curve? Minus x square minus 2. So minus x square minus 2. So this would be a proper curve and this would be a straight line, right? And our axis of rotation is minus 1, right? And our area of interest is this. If we rotate this, what will be the volume? Again, what we can do is, let's take the axis of rotation to 0. To take it to 0, we add 1 to it. So let's add 1 to this, let's add 1 to it. Yes. So what happens? Our curves become minus x minus 3 and y is equal to minus x square minus 1. Okay. So now volume would be, what is the interval? Interval is 0 to 1. So 0 to 1 of pi is there, which is higher. This is higher. That means this has a higher area under the curve. So that is the straight line. So minus x minus 3 square dx minus pi 0 to 1 of minus x square minus 1 square dx. Now here let's take minus out, because when we square it, it will become plus. So x square plus 6x plus 9 dx minus pi integral from 0 to 1 of, again here also minus, we can take it out. So everything becomes plus. So x to the power of 4 plus 2x square plus 1 dx. Okay. Now let's integrate. X cube by 3 plus 6x square by 2 plus 9x from 0 to 1 minus pi x to the power of 5 by 5 plus 2x cube by 3 plus x from 0 to 1. So this gives us 1 by 3 plus this becomes 3. So 3 plus 9 minus pi 1 by 5 plus 2 by 3 plus 1. So which gives us, what do we get? 1 plus 9, 1 plus 9 plus 27 by 3 minus, let's take this together within bracket, 15, 3 plus 10 plus 15, which gives us 9 plus 1, 10, 37 by 3 minus 15 plus 10 is 25, 25 plus 3 is 28 by 15, which gives us 157 by 15 pi cubic units. Finally, the 18th one. So we have y is equal to square root of x plus 2, y is equal to x square plus 2 in the interval 0 to 1, and our axis is y is equal to 1. Again, let's see whether they intersect each other. Square root of x plus 2 equal to x square plus 2. 2 and 2 cancels. So square root of x is equal to x square. Squaring both the sides, we get x is equal to x to the power of 4. x minus x to the power of 4 equal to 0. So x is common. 1 minus x cube is equal to 0. So x equal to 0. X cube is equal to 1. That means x equal to 1. So 0 or 1, which is the interval endpoints. So we are safe in that respect. So now let's take the axis of rotation to 0 by subtracting 1. So we get 0, which means we have to subtract 1 here, subtract 1 here. So our curves become square root of x plus 1, x square plus 1. So now our volume would be, now which is higher? Naturally, this is going to be higher normally. But since our interval is 0 or 1, if we take half, so square root of half plus 1. And if we take half square, that is 1 by 4 plus 1, which is greater? So 1 and 1 we can cancel it out. So we would have, let's square this. So we get 1 by 2, and here we get 1 by 16. So which is greater? This is greater. So square root of x plus 1 is going to be greater. So pi integral from 0 to 1 of square root of x plus 1 dx minus pi integral from 0 to 1 of x square plus 1 dx, and squaring we should not forget. Okay, so pi, if we simplify this, we get x plus 2 root x plus 1 dx minus pi integral from 0 to 1 of x to the power of 4 plus 2x square plus 1 dx, which gives us, if we integrate this, we get x square by 2 plus 2 times x to the power of 1 by 2 plus 1 is 3 by 2 by 3 by 2. So that means this becomes 2 by 3 plus x minus pi x to the power of 5 by 5 plus 2x cube by 3 plus x from 0 to 1. Okay, now let's do the substitutions. Pi 1 by 2 plus 4 by 3 plus 1 minus pi 1 by 5 plus 2 by 3 plus 1. Minus 0 we can ignore. So here what do we have? Pi is common. We have half plus 4 by 3 minus 2 by 3 gives us 2 by 3. Okay. Plus 1 minus 1 cancel out. Plus 1 by 5. Not 1 by 5. Minus 1 by 5. Minus 1 by 5. Let's see what do we get here. 5 3 is 15 times 2 is 30. So 2 is there, 5 3 is 15 plus 20 minus 6. So what do we get? 35 minus 6 is 29 by 30 pi cubic units. So I thought we are done, but it seems I missed one problem in the middle. That is the 12th one. So let's do the 12th one. So y is equal to minus 1, y is equal to minus x square, and the interval that is given to us is minus 1 to 1, and the axis is y is equal to 1. Okay, let's see whether it intersects with each other. So minus x square equal to minus 1, so x square is equal to 1, which means x equal to plus or minus 1. So they do intersect, but it is at the end points of the interval given. So perfectly fine. Now let's see what the graph might look like. So we have y is equal to minus 1 from minus 1 to 1, and we have y is equal to minus x square. So y is equal to minus x square will go like this in this interval, and y is equal to minus 1 will be like this in this interval, and our axis of rotation is y is equal to 1, and this is minus 1 to 1, and the area of interest is this, right? So what do? We have to rotate it across this y equal to 1. That means there is going to be a hole, right? So let's take the axis of rotation to 0. So which means minus 1. So basically shifting it down basically. So this becomes 0. Minus 1. This becomes minus 2. X square minus 1. So let me rewrite that. Y is equal to minus 2. Y is equal to minus x square minus 1. Okay, so now that we have this, volume would be equal to pi integral from minus 1 to 1 of, now which curve has the largest area under the curve? That is this one. So minus 2 square minus x square minus 1 square. So minus, sorry, pi integral minus 1 to 1 4 minus this minus, if we take it out because of the squaring, it will become plus. So we can expand it out by saying x to the power of 4 plus 2x square plus 1 dx. And this becomes pi integral minus 1 to 1 of 4 minus 1, 3, minus x to the power of 4 minus 2x square dx. And now let's integrate it. Pi 3x minus x to the power of 5 by 5 minus 2x cubed by 3 from minus 1 to 1. And now let's do the substitutions. 3 minus 1 by 5 minus 2 by 3 minus, now we have minus 1 here. So minus 3 plus 1 by 5 plus 2 by 3. And let's quickly add it up. We get 3 plus 3, 6, minus 1 by 5 minus 1 by 5. So minus 2 by 5, minus 2 by 3 minus 2 by 3. So that gives us minus 4 by 3. And if we evaluate this, what we get is 64 by 15 pi cubic units. So that was volume by slicing method. That's it.